So I'm going to talk about a few things today. First, I'll talk about what eBay ShopBot is. I'll explain why we don't integrate with conversational platforms in the typical way. I'll explain our approach, and then I'll show how we use Google Cloud to make this architecture possible. I'm going to focus mostly on kind of the overall, the breadth of what we built. I'm not going to go super deep on machine learning or AI. I'll cover some of that, but I'd also recommend checking out Todd Morrell's talk from yesterday. It was a pretty good coverage of kind of the basics of a bot and the theory behind that. So just to give you a sense of the scale that we operate at, these are eBay's second quarter numbers. We have 175 million active eBay buyers worldwide. We had 1.1 billion live listings on our website. We did $23.6 billion in transaction volume, and 60% of our revenue was international. This is powered by thousands of services making billions of requests per day. My group at eBay develops entirely new products using the public cloud. We do AI research and development, which includes natural language processing, computer vision, machine translation, and search. We built a buying experience for the Chinese market. And what I'm talking about today is conversational commerce with eBay ShopBot on Google Assistant and Facebook Messenger. So we use Google Cloud for almost everything. Don't worry about trying to digest this slide. We essentially started on Compute Engine. We played with cloud functions, but then we decided we wanted to kind of formalize our deployment and execution, and we moved to Kubernetes. And when you do that, it brings along a lot of other things. We use VPC for our networking, Cloud Load Balancer, and firewall rules, VPN to connect into our corporate infrastructure, DNS. We use the big data products, and then we also use the management and security products. And we're a big consumer of the utility compute products, including cloud storage, Bigtable, and PubSub. So I figured it'd be easiest just to show you a video of what eBay ShopBot is, so you can see kind of the breadth of what we built with this product.
Find me a Canon camera with a zoom lens.
All right, so the vision for eBay ShopBot was an intelligent and trusted personal shopping assistant that understands your intent and shops for and with you. This video showed a multi-turn conversational AI that was simple, fast, and conversational. Our AI demonstrates natural language processing, computer vision, and speech recognition. It curates and highlights the best deals for you and shows the unique finds. We have a size profile that allows us to remember your preferences, and as you continue to shop with us, we'll remember what you entered and personalize your shopping experience for you. And then, of course, the end result is an item card where we take you to an eBay page where you can purchase the item that you shop for. A major aspect of what we've done here is ubiquity. Instead of expecting users to come to ebay.com or our mobile app, we go to the channels where they already are. If they're in Google Assistant or if they're in Facebook Messenger, we want them to be able to shop from that interface. We adjust conversations based on the capabilities of the channel and device the user is currently in. So if you're in your kitchen and you have a Google Home, you should be able to shop using your voice from your kitchen. We allow users to interact seamlessly across devices, resuming where they left off. So going back to that example of using your Google Home, at some point you might want to actually see the results that we provided for you. So we can transfer the conversation from your Google Home to Google Assistant on your phone for you to visualize. So while ubiquity was our goal, we decided to start with two markets first. One is Google Assistant, which has over 500 million devices today, and Facebook Messenger, which has over 1.3 billion monthly users. On Google Assistant, you create an action to personalize the interface as a developer. They have over 1 million actions today. On Facebook Messenger, there are over 300,000 bots. So now I'll jump into the technical details. I'll explain what a conversational platform normally looks like and how you would interact with it. And then I talk about why we didn't do it in the typical way. So for any conversational platform you integrate with, this is kind of the diagram that you would want to build towards. On the left, you have the user's input device, like their phone. It could be Google Assistant, where they might input speech. It could be Facebook Messenger, where you upload an image, and then that's received by the conversational platform. That's converted into a request that's sent to the custom webbook that you create as a developer. You would, of course, want to validate that that request came from the platform. Then you would formulate a response and then send back the response synchronously or asynchronously to the platform. In the case of Facebook Messenger, they have a model that's completely asynchronous. With Google Assistant, you have 5 seconds to respond to the incoming request. And then finally, when the conversational platform receives the response from your webhook, it routes the output to the user. So this is Google's suggested variant of this approach for Google Assistant. Similar to what I had in the last diagram, you have the input device on the left. On the right, you have your webhook, which they use Cloud Functions for in all their samples. Actions on Google is the name of their platform that you would develop against. And what's different here is in the middle, they have Dialogflow, which is a natural language processing tool that they built. In this example, the user might say, ask eBay what my iPhone is worth. This will be sent from Actions on Google to Dialogflow. It will do the natural language processing and determine that the intent of this request was a what it's worth request. And the parameters included a product parameter with the value of iPhone X. So we actually did start with Dialogflow for Google Home. We found it to be pretty good for rapid prototyping, and it helps you get going in just a few minutes with a working integration. We built what I just described in the last page of what it's worth flow in about 5 days, and we actually were able to demo it at the keynote at this conference last year. But as we went further on that integration, we felt like we kind of outgrew Dialogflow at some point. The first issue was it was challenging to scale out development for our team. Their tool is a kind of a point-and-click website, and it didn't at the time have environment support or revision control, all the kind of tools that you as a developer are normally used to having. And so we had kind of a medium-sized team, and beyond a few developers, it became kind of challenging to work with this. There's a limited set of conversational platform integrations. So going back to our original goal of being ubiquitous, what you see there on the right is the logos from their website of all the platforms they support. And there are actually a lot more conversational platforms in the world than that. Our original integration was based on a few key categories where we imported our catalog into Dialogflow so we could do the natural language processing based on our items. In reality, our entire catalog has 1.1 billion listings. It was just way too much to actually import into their systems. And then we had a requirement for a dynamic multi-turn dialog. Dialogflow is kind of built for more static, kind of closed, retrieval-based systems. And then finally, we are a big company. We actually do have in-house AI expertise. And so we didn't feel like we needed kind of like a more basic tool. We wanted to be able to do something more advanced with our AI and NLU. So not to pick on Dialogflow, but finding the right off-the-shelf platform in this space is an ongoing struggle. Bot frameworks are in a constant state of flux. So similar to Dialogflow, there's a product called Wit.ai that was bought by Facebook. And now if you go to their website, it's almost all geared towards Facebook Messenger. It's not really considered to be a general purpose tool anymore, even though you probably could use it that way. Vendor lock-in and upselling are common. So if you were to look at Skype a few years ago, they had a bot API. And if you integrated with it within a little bit of time, you had to upgrade to the Microsoft bot framework. That went through a few revisions. Now it's called the Azure Bot Service. And that's being used to also upsell people on Microsoft Cognitive Services. So you might do a simple free integration, and within a couple of years, you might actually have to pay real money to keep it alive. So this has kind of driven us over time to build abstractions over these conversational platforms and abstract away the platform-specific details into just a kind of a closed area so that we're not impacted by these by this flux from these third parties. And then the other part of the original diagram I showed that Google recommended was the use of cloud functions. So when we originally looked at this, we ran into a few issues that made it kind of a non-option for us. One were language limitations. Our webbook was written in Scala, and it required Node.js. There was an issue with not having raw request access. For Facebook Messenger, the entire security story is based on getting the raw request, computing the hash on it, and comparing it to a header that they send you. Without that support, they were parsing the JSON, stripping out white space, and you could never get back to the original request and actually validate that it was secure. There was no SLA, so we saw issues with like uneven response times when we were trying to use cloud functions. And then there was no virtual private cloud support, which was an issue for us because we're using Kubernetes with a VPC, and in order to access our backend services, we need to be able to get through the VPC, or otherwise we'd have to expose our services publicly. So this was my slide I had up until last night when I read the news that Cloud Functions is now GA, and they pretty much addressed all these issues. So we might actually need to reevaluate it. One, they added Python support for languages. They added container support. So I don't know what that means, but I think it means that you can write a normal, or you can have a normal Docker image and run that inside Cloud Functions. They have raw request access now. They have an SLA. They have VPC support. And they even allow you to run Cloud Functions inside your GKE environment. So definitely worth reevaluating. So let me dig into our approach. This is our architecture at a high level. And I'll briefly go over each of the areas, but I'll dig into them later. On the left, we have a user's input device. They might interact with actions on Google or Facebook Messenger. The request is sent to our webhook through a Google Global Load Balancer. We'll immediately try and identify the user by looking up in our own internal identity service. From there, we'll send the request to our AI subsystem, which will process the request and generate a response. Along the way, we'll use reliable messaging that we built to make sure that the request is handled and the response is delivered. We record the request and response in our chat history, and we also do tracking through Cloud PubSub. If the user uploaded any media, like an image, we'll write that media to cloud storage. And we also have a service for doing notifications so that we can send requests or send messages to the user proactively. So this is our AI subsystem, which is the brains behind eBay ShopBot. We have a custom NLU for understanding language. We have a knowledge graph, which helps us understand the relationships between the things the user is asking about. We have a dialog manager, which takes the output of those two services and combines it with the content that we provide to formulate the response for the user. And then this dialog manager will use an AI memory to remember what the user said between conversational turns. So going into our natural language understanding area a little more, it transforms natural language text into a formal machine-readable representation. So it handles parsing. It'll take a string, break it up into words, identify nouns and verbs, and add other structure to the original input text. It does intent detection to determine what was the key thing the user was trying to do. And then it extracts any entities that it can find in the text. So basically parameters to the original intent. So the example I have here is my husband needs some new black leather dress shoes, but I want to spend less than $80. What do you have? So our NLU will go through this, and it does a bunch of things that I won't go into completely, but the key thing is it identifies the intents. So needs and what do you have tells it that this is a shopping intent. It identifies also entities, including gender, item condition, color, product, and price range. And then what you see there on the top is it did spelling correction. So husband was spelled incorrectly, so it corrected that before it tried to do the entity extraction. This is something we've had for a while. Dialogflow, I think, just announced that they added support for this yesterday. And then on the right, we have some like basic sentiment analysis that we do. So that emoji tells us something about the user's state of mind, and we can possibly tailor the response based on that. This runs in Kubernetes. We have a variety of machine learned models that we store in GCS. And when the machine starts up, it loads them into persistent SSD-backed volumes. We have a knowledge graph that is a probabilistic inference graph of eBay user behavioral data. It allows us to infer a shopping funnel. So if the user said shoes, we can narrow down the aspects to just things that are relevant to shoes. It runs with Apache Airflow to pull data out of eBay, Wikidata, Wikipedia, and that loads it. It's handled by Cloud Dataproc, which is Google's Spark implementation, and loads this into a Neo4j graph database. At this point, we have over 500 million nodes and 20 billion edges. So it requires a large amount of CPU and memory to run this, but we also use persistent SSD-backed volumes as well, and we use stateful sets so that as we deploy, it doesn't have to reload all that data onto the machine. So this is an example of what our knowledge graph looks like, just so you can understand more about it. On the left, let's say the user said shoes. We know usually what their gender is, especially on Facebook Messenger, where they have a profile where you can load information, some basic information about the user. So we can skip right to the next level question, which in the case of a male, this graph is saying that there is a higher chance that he cares about color as his next question than brand. So we can ask him, which color do you prefer, red or blue? If it's a female, we would go right to the brand question and ask, do you prefer Coach or Aldo? Our AI memory maintains memory across conversational turns. It is our dialogue state, and it also keeps track of expected future responses if we are expecting more input from the user. So going back to the flux that you see sometimes when you're dealing with conversational platforms, this is one area where you might want to build your own AI memory. Google Assistant provides a dialogue state object that you can use on their system. Something like Microsoft Bot Framework had this, and they took it away. So if you're going to integrate with something like Cortana through Microsoft Bot Framework, you would have to build this sort of system anyway, so you might as well use it everywhere. It uses Bigtable, and it's keyed on a conversation ID, which is the ID that the conversational platform provides to us for each turn of the conversation. And then what we store is the serialized version of our dialog manager's in-memory context. So as we go through each turn of the conversation, we will load this context out of our AI memory, we'll update it, and then we'll write it back out to Bigtable. Our dialog manager manages the dialog flows. It's maintained, the content behind it is maintained by editors and designers. And this is the voice of eBay ShopBot. It leverages and updates our AI memory, and it looks at the NLU output, AI memory, and the knowledge graph to generate further responses. So this can lead to another question, or it can produce results. So I'm going to jump into our Webbook and AIC subsystem interaction. So our conversational webhook is built in Node.js, Express, TypeScript. It currently lives in Kubernetes, as I said, but we could possibly port this to Cloud Functions in the future. We have built it as a single service with one router, essentially per conversational platform that we integrate with. We could split that into separate microservices later on if we wanted to. And the philosophy is for this to basically just be a translation mechanism between the third-party conversational platform and our own internal request and response format that we call Fabric API. So this is what it looks like. It's our internal model of a conversational event, and we call it Fabric because we picture our experience being on an ecosystem of channels that we want the bot to weave through. We originally built this as a REST JSON-based interaction, but we wanted to have a concrete interface to build against. And we also wanted to have client generation for the various languages that we integrate with. So we defined this interface using protocol buffers. And I'll go into each of the areas there, which is basically a subset of the things that we built for this, for the Fabric interface. Event is the top level type, and it encapsulates a lot of things that you would see across conversational platforms. So sender, recipient, conversation for maintaining context across conversational turns. We encode capabilities that might come from the request. And then we break down the event type into either a message, a post back, which is essentially a button click, and then we can differentiate between new users and returning users who are starting a new conversation with us. Our message type allows us to handle both speech and text. It allows the user to upload media, including images, audio, video, and files. It has a schedule attribute that allows us to basically delay messages so that we can kind of provide pauses in the user interaction. We also have a typing indicator in there as well that makes it look like the bot is thinking. We have a card type that's kind of a generic card that we can use to fill in with any items, but usually we use it for an eBay product. So we put in there the title, a price, a description, an image, and buttons that you'd use to interact with it. Going back to the message, we have a carousel, which is a horizontally scrolling set of cards, and we have a list template, which is a vertical version of the same thing. So one of the key things here is modeling channel and device capabilities. So we want to be able to adapt the responses to the channel and device. So we have static config based on the channel. So for example, what you see here on the right is Google Assistant showing a vertical list. On Google Assistant, this can handle up to 30 items. On Facebook Messenger, their vertical list can handle 4 items. So when we're integrating with this, we want to be able to factor in the different capabilities of the different channels. We also have dynamic config based on the incoming request. And this is especially important on Google Assistant, where you can have a Google Home that's purely voice-based, or you can have a Google Assistant on your phone that has a screen interaction. So we need to be able to factor in the two types of voice and screen-based interactions. NVIDIA Shield is one product that has Google Assistant running on it, but they didn't add a web browser yet, so we can't have the user link to eBay.com, for example. So we need to factor in all these different capabilities when we format our response. And when we do that, though, we want to avoid having channel-specific logic, because we're trying to create a bot that has kind of a consistent voice across these different channels. We want to be able to reuse that content across those channels without having logic that says if Messenger or if actions on Google. We want to be able to say, like, basically, in terms of capabilities, this is what you would show that would optimize experience for this device that the user has. So just to kind of drive that home, this is an example of what that looks like on actions on Google and Facebook Messenger. These are the basic request payloads that you would get. In both cases, the user said hello world, and we could translate that into a single fabric request, and it looks almost identical between the two. We encapsulate we include the user ID, which is our internal user ID. We record the channel ID, and we take the conversation ID that the conversational platform gave us and add that here as well. We have capabilities, and then finally in our message list, we include the original hello world text message. The response is pretty much the same thing. In this case, our AI responded with, you said hello world. And we have channel-specific code in our webhook that can translate the fabric response into either actions on Google or Facebook Messenger. And what you see there is what that looks like on each of those platforms. So at this point, supporting additional channels has become more of a business decision than an engineering one. We have a common backend shared by all channels, and we just have to create a new express router in our app and set the endpoint for that in our conversational platform. The biggest challenge is then mapping the external request and response format into our Fabric API and accounting for any unique capabilities that that channel might have. We've already validated this approach, so beyond Google Assistant and Messenger, we've done this integration with Cortana and Skype, SMS, Slack, and we've got something basic working that we know we could easily scale out if we chose to take our business in that direction. So I'll go into some of the supporting systems now. These are not major systems or major components of what we built, but I think it's interesting to look at them because they were built heavily leveraging GCP. And it's the sort of thing it would take a lot more work to build off GCP, like on a traditional platform. So we built our chat history in Bigtable, and we want to archive incoming and outgoing messages. So some use cases include internal dashboards to visualize conversations, analytics, retraining our AI models, and hand over to a human operator. We basically are just trying to record a JSON serialized version of the message. We include some metadata. We have a version attribute that allows us to know how to parse that message. We include the channel, and then we include a send from user value to basically know if it was a request or response that we're recording here. The key thing here, if you spend any time with Bigtable, is on the key design. And this kind of aligns with Bigtable's best practice for how to build a key. But we want to be able to retrieve based on a user ID. So that's the first component of our key. Then we also want to be able to make sure that the messages are in order according to the time that the user interacted with our bot. So we use a timestamp. We wanted to be able to get those most recent first, so we reverse the timestamp. And then we use a random number in case there are multiple concurrent writers. We don't want them to overwrite each other. And then if we're recording multiple messages at once, we have a batch ID that's sequential for that batch. So it all kind of comes together and gives us one kind of easy to interact with, lightweight chat history system. We actually built a reliable messaging system in Bigtable. So the thing here is we want to make sure that every input from the user gets a response. If something goes wrong in our backend and we drop a request, it looks really bad. It essentially looks like the bot is just not functioning very well, it's low quality. And it also aligns with Facebook Messenger's interaction with webhooks, which is they'll send you a request and they expect you to return a 200 response. And if you don't, they'll retry it again in 20 seconds. If you return too many failures, they'll disable your bot altogether. So no matter what happens, we want to be able to return a 200. So the system we built takes a request from Messenger, and we immediately write it to Bigtable. Each user has their own queue, which is represented by a row in Bigtable. And the message is written to a column with a sequential, monotonically increasing ID. We'll try and send the message if we can right away. But if something goes wrong, a worker will scan the table, it will pick up the row that still has outstanding messages. It will automatically try and lease the row, and then it will send the messages one by one. After all the columns are deleted, it will release the lease, and then all the messages should be sent at that point. So this ensures ordered at least once delivery. We do have some edge cases where it could possibly result in duplicates, but we figured that was better than having no responses at all. And this is something we built over a year ago. We haven't had any problems with it, really. You have Bigtable issues that are kind of within their SLA. So we have blips here and there. It hasn't really impacted users. And every time we've had one of these blips, it's recovered on its own. So conversational platforms will deliver media in different ways. On the right, you see an image being uploaded from Facebook Messenger. And when that's sent to our service, it's in the form of a short-lived URL. And other platforms might deliver this media in different ways. So we want to extract those details from our backend services. So at the edge, in our webbook, we immediately record any uploaded media into GCS. And then the GCS key is what we pass around to our backend. And once again, it's something that just works for us. It was very fast for us to implement this, and we haven't had to think about it since we launched. We built our notification system with Cloud Datastore. So this is what proactively sends messages to users. We handle package tracking events, deals, editors picks, and marketing campaigns. User subscriptions are stored in Datastore. So the user will subscribe or unsubscribe to a notification through their conversational interface. It will be sent to our notification service, which records that in the notifications DB. We have Quartz cron jobs that run periodically to check to see if any notifications need to be sent. It will receive events from eBay to know when package tracking updates happened. And we also call into our deals API to look up any new deals for the users. When this notification system runs and is invoked by Quartz, we get a transaction to essentially lock the processing of the notifications to a single worker. And this is one area we actually might want to revisit our decision to use Datastore. We used it at the time because it was new, and we wanted to see how it performed. And we've run into rate limiting issues with it time and again. So probably what we would do instead is use a traditional relational database or Cloud SQL or something else like that. We built our analytics system on GCP. And what you see here is actually pretty standard. Our service will track requests and responses in Cloud PubSub. We have Cloud Dataflow that does a stream process of any events, and it persists the results into cloud storage. What you see on the right is a Data Studio dashboard. It's not ours, it's just a sample, just to give you an idea of what it looks like. And when the user loads the dashboard, it goes through BigQuery to load the external data from cloud storage, summarize it, and then present it to the user. So tying this all together, I'm going to show a video of Google Assistant in action. And I didn't go into localization or multi-region support, but just a heads up, this is done from the viewpoint of an Australian user.
Ask eBay to find me a Kate Spade bag.
Okay, getting eBay.
Got it. Looking for a color that's black, brown, or something else.
Black.
Great. Do you want a style that's shoulder bag, messenger and crossbody, or something else?
Shoulder bag.
I looked through 7 options on eBay and the best deal on this item is $95. I have more info on this deal for you. Is it okay if I send that to your phone?
Yes.
Okay, so just to summarize, what you saw there was a few things that I talked about in action. We showed our AI. So when the user says, ask eBay for a Kate Spade bag, our NLU will try and parse that input. It will go to our knowledge graph and try and find additional attributes about Kate Spade bags, so including color and style. It uses our dialog manager to process the output of the NLU in the knowledge graph, and then takes the content that it has internally and formats responses. It uses the AI memory so that it remembers across these 3 turns what the user inputted. And then finally, it returns results. We use the Fabric API so that we can translate from the conversational platform, Google Assistant's request and response format, into the format that our AI understands internally. And then we factor in channel and device capabilities. So the initial interaction was through Google Home, and it's a completely voice-based interface. And we had to tailor the response with the expectation that the user didn't have a screen to look at. So at the very end, when we had results to present to them, we asked them, do they want to transfer this conversation over to their phone on Google Assistant? And that's what happened there. We loaded the final results out of our AI memory, and when the user came in from their phone, we presented them with an item card showing them the results. So in summary, eBay ShopBot is an intelligent and trusted personal shopping assistant available today for Google Assistant and Facebook Messenger. We ran into issues that caused us to not use Dialogflow or the traditional way that you would integrate with a conversational platform. We built our own AI stack, and we have a request response format that we translate external formats into so that we can handle them in a platform neutral way. We built this all on Google Cloud and to help make this entire architecture possible. All right, thank you.